Automatic drip irrigation system using wireless sensor technique powered by solar system. Abstract: India is developing country and economic growth of India is depending upon agriculture field. So improvement of agriculture field is very important now in our country. The 70% land is agriculture land and more than 60% people is depending upon agriculture field. The farmers working in the farm and this are dependent on the rains, river, pond, and bore wells. Even if the farmland has a pump, most of the time it is being kept standstill due to non-availability of grid power in the remote areas. If the solar power is harnessed, an agricultural pump can run during day hours without depending on grid power. The important objective of this paper is to establish an automatic solar-powered drip irrigation system by using wireless sensor technology, WSNT, by integrating solar system, Arduino microcontroller, soil moisture sensor, water pump etc. Keywords: drip irrigation, solar panel, soil moisture sensor, microcontroller, wireless network, timer, GSM. Introduction. Water is a basic component of all life. Water is also a very precious natural resource that must not be wasted. If too much water is applied, the problems rise up depending upon the soil texture. Irrigation is artificial way of watering the soil for the proper growth of the plant. It is mainly used in the places where rainfall is less. Irrigation also helps to suppress the weeds growing in the agricultural fields. The old methods used for irrigation, it was manual irrigation using buckets and watering cans, by using sprinkler irrigation, localized irrigation, drip irrigation etc. But by using these techniques we can't predict the amount of water that is to be watered or the sufficient quantity of water that a crop needs. 1. Wireless technologies have been growing fast in recent years. These technologies depending on the range of communication between sensor nodes. This wireless sensor-based system monitors the water requirement for a crop continuously and sends the data to the main system which controls the flow of the water. The sensors used for measurement of soil moisture can also measure temperature of the soil to solve the problems related to soil for a particular crop. Soil moisture sensor senses the environmental and soil conditions which can be sent back to the system for achieve the excellent and efficient performance. System measures information of soil moisture content stored in it and sends it to the main system with the help of microcontroller and other electronic devices. 2. In recent few years, rapid growth in irrigation system. The user communicate through SMS. Irrigation depending on soil moisture reading from sensor and type crop and automatically irrigated the field. The information exchange between designing system via SMS on GSM network. 3. 2. Methodology. The various components used for the developing GSM-based automatic drip irrigation system using wireless sensor technique powered by solar system is shown in the following figure. Solar panel, MPPT, charge controller, rectifier, transformer, auto changeover switch, battery bank 12V to 5V, DC power supply, Arduino Uno microcontroller, soil moisture sensor, GSM 900A module, relay controller, DC jet motor, clock, timer. From these we uses the solar panel. These panels are nothing but the PV cell. In these it connect the solar panel to MPPT solar charge controller and then it connect to battery. Solar charge controller are used for preventing the overcharging the battery. In these system relay will used as switch, it will connect to microcontroller and submersible pump. Microcontroller receive the voltage signal from the soil moisture sensor and it give the command to pump. Also GSM and Bluetooth technology will be used for communication purpose and also collecting the information from the field. Drip irrigation system. Drip irrigation means distributing water directly to the soil at a very low rate. A system has small diameter plastic tubing fitted with outlets called emitters or drippers. Drip irrigation is more efficient because the water soaks into the soil before it can evaporate. The water is also applied close to the plant root, providing a high moisture level in the soil. The main components of a drip system consist of a main line, valve, backflow preventer, pressure regulator, filter, tubing adapters, and fittings, drip tubing, emitters and an end cap. These are shown in the figure 2, 4. Design of pump. It was decided to keep a water tank nearer to this land and watering to be done to this selected land by using a small submersible DC pump which is expected to run for about 3 hours/day with the help of solar panel and battery. A20W, DC, submersible pump shown in figure 3. Specifications. DC voltage range 12V. Current range, 5A. Operating frequency, 50 Hz. Power consumption, 60W. Design of battery. In the lead acid battery with 7.5 Ah, 12V capacity which will deliver maximum voltage 12 to 14V and maximum current 1.4A has been selected. Design of solar panel. In the solar panel it will contain nothing but photovoltaic cell, PV cell, This photovoltaic cell uses sunlight to generate electricity. The generated power is the product of voltage times the current, i.e., P equals Vxi. The amount of electrical power generated by photovoltaic cell, it depends upon the amount of solar radiation that hits at PN junction as well as the percentage of solar radiation it actually converts into electricity. Solar panels are used to liberate irrigation from the shackles of load shedding. The requirement of water is judged and information is transmitted to the solar circuit, which modifies its configuration such that it provides enough DC power to drive the pumps and fulfill the assigned task. 5. Specifications. Rated voltage, 12 V. Rated current, 1.6 A. Total capacity, 20 W. Auto changeover switch. Specification. Rated current, 20 A. Rated voltage, 12-18 V. Specifications. Rated voltage, 12 V. Rated current, 20 A. Design of step-down transformer. A step-down transformer is a device which converts high primary voltage to a low secondary voltage. In a step-down transformer, the primary winding of a coil has more turns than the secondary winding. Step-down transformer equation. The formula used to design a step-down transformer is where Ns equals number of turns in secondary, Np equals number of turns in primary, Vs equals voltage in secondary, Vp equals voltage in primary. So from that we use 12V and 5A will be used. Design of soil moisture sensor. Soil is non-conductive by nature, but presence of water in soil increases its conductivity due to the presence of conduction ions in water. Soil resistivity is a measure of a soil's ability to retard the conduction of an electric current. 2,6. Specifications. Operating voltage, 3V 5V. Dual output, 4-wire interface. Panel PCB dimension, 3 cm x 1.5 cm. Soil probe dimension, 6 cm x 3 cm. Arduino Uno microcontroller. In this present study, Arduino microcontroller has been used. The different pins, digital, analog and power supply, of Arduino. Arduino is genesis of the proposed system. The center of all operations taking place in the system. Components are connected to Arduino through different ports and are dependent on its instruction. Arduino has been used because of its versatility. 5. Specifications. Operating voltage, 5V. Input voltage, 7-9V. Input voltage, limits, 6-20V. Digital I/O pins 14, 6 provide PWM output. Analog input pin 6. DC current per I/O pin, 40 mA. DC current for 3.3V pin, 50 mA. Flash memory 32 KB, of which 0.5 KB used. By bootloader. SRAM 2 KB. EEPROM 1 KB. Clock speed, 16 MHz. Digital clock timer. Specification. Input voltage, 230V. Output load current, 10A. GSM 900A digital GSM unit. The Global System for Mobile Communications is a standard set developed by the European Telecommunications Standards Institute, ETSI, to describe technologies, 2G and 3G. General Packet Radio Service, GPRS, is a packet-oriented mobile data service on the 2G and 3G cellular communication systems. Global System for Mobile Communications, GSM. GSM-based motor control board is shown in figure. GSM contains a subscriber identity module, SIM. Farmers can communicate with this SIM number, 7. Nowadays the GSM module is used for remote control performance such as gate control and temperature control. GSM/GPRS component consists of a GSM/GPRS modem assembled equally with power supply circuit and communication interfaces for computer. These are pretend for specific cellular network, GSM/UMTS/CDMA, or specific cellular data standard technology, GPS/SIM. 3. 3 experiments. Based on the R project hardware model, many experiments are conducted to understand the functional behavior of soil moisture sensors. Batteries charging voltage, batteries discharging voltage while keeping the solar panel disconnected from the circuit, and batteries discharging voltage while running the pump drawing power from batteries and simultaneously it is also kept in charged condition from SPV. The following table shows the voltage developed by the moisture sensor with respect to addition of water. It was observed that when the soil was completely dry it was developing 5V, and when 60 ml water added, the soil turned into completely wet as shown in figure. For this complete wet, the voltage developed from the soil sensor was 0.98 V. Arduino Uno microcontroller receives the incoming voltage signal from the moisture sensor and gives the moisture content in the soil. A LCD display was also connected with the Arduino to display the moisture content and pump on/off status. This system can run either with electricity or solar power. The pump can run without solar panel, I.E. receiving AC power from the grid and then converting the DC power with help of the rectifier. It is suggested to use automatic drip irrigation system using wireless sensor technique powered by solar system with batteries to get longer life to the pumps. For results, applications and future scope. Results. As the result of our project, messages are sent with help of GSM to the farmer. That messages contains the information about condition of farm. If the soil is dry, then motor gets automatically turn on, and if soil is wet, then motor gets automatically turn off. So accordingly the messages will be sent to farmer with help of GSM. Below image shows how actually the messages will send to the mobile number of farmer. From the table, the moisture sensor which will give voltage output W.R.T the water content in soil. If the soil is completely dry, the voltage output from the sensor would be 5 V, and if the soil is completely wet, then the voltage output would be 0.98 V. Hence, this 5 V relates 0% moisture and 0.98 V relates to 100% moisture. The following figure shows the calibration curve. Prepared for sensor output voltage versus percent of moisture. Based on the experiments, it has been decided to switch on the pump whenever the soil moisture goes down to 65%, i.e., at sensor output voltage at 2.75 V, and switch off the pump when the moisture level reaches to 75%, i.e. sensor output voltage at 1.5 V. Applications. 1. This system can be used in gardens and provide proper irrigation to garden plants. 2. This system can installed in greenhouse where different parameters needs to be monitored and controlled with small changes. 3. This system can also be used in poly houses. 4. The system can be used for study of crops under different water and pH condition. 5. The application of nutrients is quantitative and inaccurate, therefore is adapted for perennial crops like citrus, fruit trees, and crops grown on heavy soil. Future scope. 1. We can enhance the performance of automatic irrigation system by connection it with IoT, Internet of Thing. We can versatility by connecting it with many device. 2. In future we try design this system much smarter where we can make such system which include data of all crops, means which fertilizer is now required for crops and what will be the amount we can provide fertilizer to crop, which season is most preferable for crops, atmospheric condition throughout the year, etc. 3. And also we try to give some advanced features such as detection of broken pipes and identification of sensor damaged position. Conclusion. A remote control for drip irrigation is most beneficial approach for the farmers. This system reduces the extra manpower of the farmer for his farm, like supplying water to plant. Solar power provides sufficient amount of power to drive the system. The subcomponents of solar-powered automatic drip irrigation system consists Arduino microcontroller, Bluetooth module, GSM module, solar panel, battery, charge controller, and other accessories such as submersible pump, drip irrigation kit. With the help of this system, the pump can run minimum 5 hours per day with the help of solar panel and battery, and 45 minutes per day without battery from the solar panel. The pump status and moisture value was obtained on mobile phone with help of GSM module. Also this system monitor the water-soluble fertilizers such as urea, potassium, nitrate, ammonium sulfate, ammonium nitrate, etc. The system provide a real-time feedback control module which monitor and control all the activities of drip irrigation system efficiently. To overcome the necessity of electricity and ease the irrigation system for our farmers, the proposed model can be suitable alternative. Also with this system one can save manpower and water to improve production, which ultimately increase the profit.